So as promised, here's some more practice. We're going to do long division on these two problems. This is a made-up problem, came out of nowhere. This is the one we did in class together, but there was an error. So I'm going to show you it was a very dumb error. I'll fix it in a minute. And then I also, before we did anything else, wanted to talk about letter H. So this is also from the algebra techniques about what we need to simplify the radicand first. But I didn't want you to sit there and struggle and wonder what it is you're supposed to be doing. And in this situation, we're going to be expanding, which means I'm going to rewrite this. That's really blurry. I'm going to expand that. I'm going to write it down twice because that's what the outside exponent says. Because there was an 2 on the outside. I'm going to distribute double rainbows. So I'm going to get x to the 4th power plus x squared plus 1, x squared times x squared, x times 1, 1 times x squared, and so on. So I end up with x to the 4th plus 2x squared plus 1. And I end up taking the interval from -7 to -6 dx. And then you're going to do it from there. No big deal. So don't forget about the simple things that we know how to do. The other thing that can come up that I did not do an example of, and I've chosen not to do an example of, is to complete the square in order to take the derivative, take the antiderivative. I chose not to put that on our assessments because it's a little tricky. And if you're complete, and I don't know that it's as helpful as where I wanted to focus. This shows up more frequently. And then some of the complete square techniques. Okay, so we did this one in class. It's right here, and then right at the end of class, when everybody had left, almost, somebody asked a question about, well, where did this 1 come from? And it wasn't supposed to be 1, it was supposed to be 2. But I'm going to do it again, just really slowly. So, and do it right. So that's what's going to change from what we did in classes. I'm not going to make that mistake. So we're going to do long division. And long division is tricky and hard, and we might not remember, but it's still okay. It's not the end of the world. X plus 4 is going to divide into x cubed plus 3x squared minus 7x plus 1. And again, we did do this in class. We're going to do it again anyway. So I think to myself, what do I need to multiply x by to make x cubed? And the answer is x squared. X squared times x is x cubed. Good, that's what's supposed to happen. And then x squared times 4 is plus 4x. And as we know, we're supposed to then subtract what we got. When I subtract that, I end up with negative x squared. I bring down negative 7x. And then I think to myself, what should I multiply x by to get negative x squared? And that would be negative x. So negative x times x is negative x squared. Negative x times plus 4 is negative 4x. And then I subtract. So I'm subtracting with the pink. And that means change signs of both terms. Okay, so now I'm subtracting, and I get 0, that's what's supposed to happen, and negative 3x. And so then I think, I'm bringing down the 1. And so then I think, what do I need to multiply x by to get negative 3x? And the answer is negative 3. And so negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And then I subtract, which gives me 13. So my remainder is 13. And so then I add 13x plus 4 to the end of that. And so I've rewritten this as this. And just to be sure that we didn't lead you astray, I didn't do this in class because there wasn't a lot of time, and I didn't want to keep you any much longer than I needed to. I'm just going to put those two equations into the graphing calculator and show you that they are equivalent. So I have x to the 3rd power plus 3x squared minus 7x plus 1 over x plus 4. So it looks like that. And if I zoom out, there's more going on here, but we'll just leave it there. Looks like that. Then I'm going to do the other one, which was x to the second power minus x minus 3 plus 13 over x plus 4, and see how they are exact. When I click off, it turns purple because it's red and blue on top of each other, so it's purple, which, you know, is my mood today. Purple mood, purple graph. Okay, so that's that. So back we go. We've demonstrated that yes, they are equivalent. We didn't make a mistake. It's just a quick way to check yourself. And now we can continue with our calculus. So I'm going to just go to a different color. And so I have the integral from 2 to 5 of my new expression, x squared minus x minus 3 plus 13 over x plus 4 dx. And I'm going to put that in parentheses because I'm integrating each part. You know. And so I get x cubed divided by 3 minus x squared divided by 2 minus 3x plus the integral of this is natural log, but the 13 is just going to sit there. ln of absolute value, x plus 4. Again, where x, well, and since the derivative of the inside stuff is just 1, we're all set. No big deal, nothing weird. Now, I'm not going to add a plus c because I have endpoints. So I am going to evaluate from 2 to 5. Okay, so that means I'm going to go ahead and plug 5 in and then subtract plugging 2 in. Okay, so I have my original, something cubed over 3 minus something squared over 2 minus 3 times something plus 13 times the natural log of something plus 4 the value. So I'm going to put into that 5 everywhere there was a something. I'm not going to clean this up very much. I'll just clean it up a little bit more than I did in class. 125 over 3 minus 25 over 2 minus 15 plus 13 natural log of, and I don't need absolute value anymore. 5 plus 4 is positive, so just 9. But I have that there, like if this had been a negative number, then everything would work out fine. Okay, it's really important, especially with this kind that we remember to put that absolute value on. And then I have to minus from that, plugging in 2. So, do that up here. Again, something. Use the blue. Something over 3 minus something cubed squared over 2 minus 3 times something plus 13 ln of something plus 4. And so now something, and I'm closing my big parenthesis, and now something is 2. And I plugged in 1 in class, except for here where I plugged in 2. So I don't know what my brain was doing. So minus, and I'm going to go ahead and leave the parentheses there, 2 cubed, 8 over 3, 2 squared, minus 4 over 2, minus 6, plus 13, ln 6, close the parentheses. And if I needed to go further, and I did not have access to a calculator, I'm going to get my thirds together. So I've got 125, just use purple, 125 over 3 minus 8 thirds. That's 2. So I'll leave the 25 halves. And then I've got negative 15. I'm just going to write this negative 15 plus 2, because minus a negative, plus 6 minus a negative. Then I've got my 13 ln 9 plus 13 ln 6 blah 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 125 minus 8. I'm going to simplify with this. Okay, so I plugged in, like I said, and then I rewrote this. So 125 over 3 is 119, minus 8/3 is 117 over 3, so that's just 39, so that's where 39 came from. Negative 15 plus 2 plus 6 is 7, and 25 divided by 2 is 12.5, which led me to 19.5. Okay, in case you're wondering where that came from. Over here I played natural log games. I've made 13 the exponent of both of these, and since they're added together, that means the arguments were times. Then I brought the 13 back out front, and 9 times 6 is 54. And so that's where that came from. And there you go. There's the answer. Now, again, free response. This is my answer. I'm not doing any of that. And some of you are oversimplifying on your free response. I'm not doing any of that. I'm stopping right here because I'm going to make a mistake. I paused. It took me nearly 5 minutes to simplify this before I turned the camera back on. I just didn't want you guys waiting around for me. Okay, so don't go here unless you have to. Stop right there. All right. Now with that said, we're going to do this example. We're actually going to use another piece of paper because it looks like I have maxed this one out. Didn't know I would, but I have. So I'm going to move this example over to this page. Just write it down. And I decided not to do I'm going to do an indefinite interval instead of a definite, just for contrast. And so it was x cubed minus 5x squared plus 2x plus 7 over x minus 8 dx. Okay, so I'm going to do long division. I'm going to go ahead and set that up. Let's see what happens. So I've got x minus 8 divided into x cubed minus 5x squared plus 2x plus 7. And so I think to myself, what do I multiply? I need to make x cubed, so I'm going to multiply by x squared, which gives me x cubed minus 8x squared. Then I will subtract. In this case, we'll change to that, which will give me 3x squared, bring down the 2x, and the sign with it. What do I multiply by? I'm going to multiply by plus 3x. So then I'm going to get, sorry, that should be purple. So then I multiply by 3x. 3x times x is 3x squared. 3x times negative 8 is negative 24x. Then I subtract. And so then I get 26x, bring down the 7. You can tell I made this one up, kind of ugly. That's okay. What do I need to multiply by? 26. 26x minus, calculator, in case you're wondering. See where I did all my calculations down there. 8 times 26 is 208. Then I subtract, and I get 215, which should be in pink. 215. Okay, and so my new integral is, I'm taking the integral of this purple thing, x squared plus 3x plus 26 plus 215 over x minus 8 dx. because I just rewrote that as this, plus the remainder over the divisor. And so then I'm just going to go from here. No big deal. Antiderivatives. Antiderivative of x squared is x cubed divided by 3. Antiderivative of 3x is 3x squared divided by 2. Antiderivative of 26 is 26x. Antiderivative of that crazy fraction is the constant times the natural log of the absolute value of x minus 8, that, plus c, which is why I did not do endpoints on this one. There you go. There you have it. Are there any questions? You'll have to ask me in class. I'll see you on Wednesday. Have a great day, everybody.